Okay, so today we are giving LeetCode Biweekly Contest. I'm very inconsistent in LeetCode, but I'm free today, and there is no Code Forces contest today, so just giving it for fun. There are four questions, I hope, and let's see how many can I do. Okay, so the snippet thing, I think if I need any, I can take that. So I will open VS Code at that time. Okay, my alarm. I don't know why. Okay, problem list. Yeah, what is this? Okay, it was not working a while ago. However, let's open each question. Perfect. Okay. Small pair with different frequency. You are given an integer array nums. Consider all pairs of distinct values x and y from nums such that x less than y, x are different frequencies in nums. Among all such pairs, choose the pair with the smallest possible value of x. If multiple pairs have same x, choose the one with the smallest possible value of y. Return integer x, y, no valid pair exists. Frequency of x, y is the number of times it occurs in the array. 1, 1, 2, 2, 3, 4. Okay, so x less than y and x, y have different frequencies. X less than y, x, y has different frequencies. Choose all pairs with the smallest possible value of x. Among all such pairs, choose the smallest possible value of x. Okay, if multiple has same x, choose the smallest possible value of y. Okay, perfect. So I think I can map frequency, then I can just check like for one I will try, yeah, just trying will give that whole thing. We're just brute forcing it. Okay, the values are thumbs up by 100. So let's name it hash. So I think I should make it 1. Now hash of nums of I plus plus, getting the values. Now there's a vector. Initial answer is -1, then I think I cannot be 0, right? Yeah, less than 100 I plus plus, and j equals to I plus 1, j less than equals to 100, j plus plus. Now if hash of I and hash of j, I can do it in, okay, yeah, it will also work. Okay, I have to do and hash of I not equals to hash of j. In that case, answer equals to I comma j, right? And return answer. Otherwise, just return answer 2. Now I want to run the code. Control this. Okay. 1 3. Let's just submit it. Accept it. Sum of k digit. Question 4. Question 3. Question 2. Merge close characters. We are given a string is consisting of lowercase English letters and an integer k. Two equal characters in the current string s are considered close if the distance between their indices is at most k. When two characters are close, the right one merges into the left. Merges have merges happen one at a time, and after each merge, the string updates until no merges are possible. Return the resulting string after performing all possible merges. Not if multiple merges are possible, always merge the pair with the smallest left index. If multiple pairs shares the smallest left index, smallest right index. Okay. A B C A. K goes to 3. A B A. A will merge with this A, right? Character A at index I equals to 0, I less than 3 are close as 3. Okay. A B C A. This A will converge in one piece, and yeah, perfect. Y this Y also will get lost. Then this Y will remain the same. Yeah, got it. This Y will remain the same because in this case this Y will, but we have to take the smallest one from left to right. This will simulate, right? Okay, so now I think we need to make an offset. I can take map for simplicity. Just taking it will make it login, whatever, who cares. So first we are taking this, and I think I should do something else like here, and from 1 then equals to 20. Okay, so MPP of S of I, if it has, we have seen it before, right? And it is at k distance at most. So I minus MPP of S of I, that is less than equals to k. In that case, okay, now also we have to take the offset. So in that case, it will be offset plus plus up to an empty string. Then we are pushing back the, no, we will not push back the right character, and we will update offset, and I think that is it. Yeah, else and we are pushing back the ith character, and we'll return as answer. I think this is okay, hopefully. ABC ABCA, okay, it is wrong. YBZ 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 YB, okay, this will be YBZ, then this Y will get cut off, this Y will get cut off, this B remains, this Y will get cut off by this Y, this Z will remain, this Y, how, there is some problem, I think. If we are not in that character in case, yeah, perfect. I minus MPP of S of I minus offset less than equals to K. Like here, 3, 1, 2, 3, 4. Yeah, perfect, perfect. Offset is working, but why BZ, why BZ? How? 2, 4, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. How? 7, 8. Okay. I then MPP of S of I. Let's see. 3 and 7. K equals to 2. It's also output offset quit 210. Perfect. 411 732 7 1 2. It's 1 2 3. Perfect. Okay, okay. The offset will will not be the same because that is also increasing. Yep, yep. Okay. Um, will it work? Yeah, it will. Will it work? Like prefix, so the offset from there, yeah, the offset before that position and offset now. Yeah, now this will be brief of offset MPP of S of I. ABC ABC A XYZ VYZ. Perfect. Minimum operations to make the array parity alternating. You are given an integer array nums. An array is called parity alternating if for every index I parity alternating. Okay, nums of I, nums of I have different parity. In one operation, you may choose any index I and either increase nums of I by 1 or decrease nums of I by 1. return an integer array answer of length 2 where answer of 0 is the minimum number of operations required to make the array parity alternating. Answer of minimum number of operations minimum possible value of maximum number nums minus minimum nums taken over all arrays that are parity alternating can be obtained by performing exactly answer 0 operations. Okay, so first we'll see the answer 0 minus 2 alternating alternate. This is not alternating. To change this and this, you have to change 2 whatever you do. So the thing is that if that is minimum and we are changing that, then we'll change that to, yeah, it is easier. I think there are 2 cases only. We will try each cases. Right, not right. Why am I telling right every time? Whatever. So the take one is first even then odd. Mm, we should also assign them numbers. What can we? 1 in 5, 1 in 9. Okay. The answer is firstly the answer I think can make it at least 0. It will be at least 0, right? Now we will check for if I and 1. We'll check for we'll make it odd. Now okay, but the thing is that we can make it. I think we should get this right. Okay, wait. Make the numbers in odd indices. Take the maximum in odd indices and take the minimum in. Okay, wait. Let's make it there and it's simple. Okay, I plus equals to 2. Perfect. Now that equals to 0. The odd number, then odd number, we are not changing them, right? So but if it is not odd, then then if it is maximum, then a of 5, else else we are making um, if okay, if we are also changing that, we can take it taking if this odd, right? If it is even, if it is even, in that case, if it is odd, then we are increasing. If it is even, then we can increase it. Else, a of n. But the thing is that we cannot increase and decrease at the same thing. In that case, okay, wait. Nums can length can be 1. So if it is 2, still can put maximum and minimum. So first we will try to make it max. Then if it doesn't happen, then try to make it minimum. This is not good. I think I should change it. First find the answer, then change it, right? Maximum and minimum. In one case we will maximize the maximum. Another case we will minimize the minimum. We'll take minimum from the previous case. Okay, no, something like that. Okay, if every number is same, then only the maximum and minimum can be different. Otherwise the increase is by 1 only. Otherwise the increase is only 1. So it doesn't matter. If every number is same, the case for if every number is same. Sorry. Nums of not equals to val, then we'll make flag true. Now note of flag cout in by 2, sorry, cout not float, return in by 2. And the second thing is the value change, right? So that can be at least 1. But now if nums, if then the change can be 1. Okay, so if n is greater than 1, then 1, else 0. Now there are different numbers, then we will try those values. I plus plus now odd position node if I and 1 with, so if nums of I and 1, in that case we'll just take the maximum and minimum, right? Maximum and this will be 1 in I. Now if they both are same, okay, in other cases we can reduce it, but it will reduce by 1 only. Can increase it, but it will increase by 1 only. If different numbers exist, then there will be a number that is -1 or +1, right? Or more than that. So that will not be the, it will not change the things a lot. Now in the else cases, if nums of I and 1, in this case we will take this and the other case will not change them, so like this, and this will be answer 1 plus plus, and here will be answer 1 plus plus. Now we need to take also answer 2, val 1, val2 val1 equals to mx minus m1 mx equals to minus 1 in n m equals to 1 in n. I think I just should copy this. Now in this case, odd index, even number. So and 1 now and modulo 2 to 0 and here also modulo 2 is equals to 0. Now answer 2 equals to answer 2 sorry answer 2 now if answer 1 less than answer 2 in that case answer equals to answer 1 comma val 1. Is it answer 1 greater than answer 2? In that case answer equals to answer okay. Or answer 1 equals to answer 2 and val 1 greater than val 2. Else case just this. Answer 2 val 2 and then just return it. What? Terminate call after throwing an instance of standard length error with a factor larger than max size. Oh my god. Output 2 0 2 0. What? Inexcessive maximum 2 0. How 2 0? How? Val 1 equals to. Okay, I think yeah. Val 2 equals to maximum minimum 2 8. Increase now 2 by 1. Decrease now 3 by 1. 6 minimum possible. But if we increase this, why? Oh, where? Oh my god. You're not able to take the alternative. The minimum possible value. Sure. The minimum possible value. We're trying to make minimum possible value. So we need a base reference. If something is below that, we will try to increase the number. Right. Just maximize it. Decrease the maximum, increase the minimum. Two, 6, 1, 3, 0, 0. Answer 2, 7, 10. Okay. 9 minus 8 minus 2, 9. 9, if we increase 9, that is going to be 4. But no, change this and this or this, these two. In that case, if we change these two, can decrease it to 8, can increase it to 9, sorry, minus 7, minus 7 to 8, minus 7 to 8, minus 15, but there will be 9, so that will be 16. Yeah, that is perfect. This will be 16, but it's not wrong. 9 minus 8. Yes, I am taking it wrong. Am I taking it wrong? In that case, we are accelerating the max. No, no, no. I'm doing it right. Maximum costume, maximum minus. Max, okay. Use test case. Last one, okay. Okay. Now put the last maximum minimum. In this case, okay, the maximum is 9, minimum is minus 8. No. In this case, the odd index has even number. Odd index has even number. Okay, so odd index, even number. Then minus 2 will be okay, the condition is wrong. If val1 less than, yeah, that was the problem. 216. Okay. We are given three integers L, R, K. Consider all positive integers consisting of exactly k digits, where each digit is chosen independently from the integer range L to R inclusive. Consider all possible integers consisting of exactly k digits. Okay. If 0 is included in that range, leading zeros are allowed. 0 is included in that range, leading zeros are allowed. If 0 is included, leading zeros are allowed. What? Return an integer representing the sum of all such numbers. Since the answer may be very large, return it model. Return an integer representing the sum. L equals to 1, R equals to 2, K equals to 2. L equals to 1. Integer range L to R inclusive. Output 66. All number from K equals to 2. Digits in range 1 to 2. Okay, digits in range. Now L is, yeah, 0 to 9. Okay. Now K equals to 2. 1 1 1 2 2 1 2 2. This is combinatorics question, I think. 0 to 1. So 0 to 1. Okay, 0 is included in the list. I think in this range 0 is included. Got it. Leading zeros are allowed. Yeah, got it. Pure combinatorics question this is. See, the digits are same. Yeah, if the carry exists, then it will not be the same. Now, I think I got it. K 10 to the power 9. 10 to the power 9 digits. Okay, 10 to the power 9 digits. In that case, 10 digits, 5 to 5. 10 to 5 or anything can happen. So, number of, we can get the number of different arrangements, right? Now, every number will is equally likely, so in every position it will contribute a value. Yes. Now the sum of those values will be just adding every value and the 10's power of it. So the value will be uh, you can express it in some series, and but k is 10 to the power 9. Okay, so we get the different arrangements and we take equal contributions, right? Now for equal contributions, 0 1 10, yeah, equal contributions, we add them and we have to see the carry to. Now the modulo that operation. Okay, I think we need some properties. Okay, is it basically 1111 something like that multiplied by a value? We can get that value pretty easily. And okay, so this is basically 111111. This multiplied by some value. So what can we do? If this is, we can take modulo this, we can take modulo this. This is easier to get, but this part is not easy to get. So how to get modulo so many numbers? K digits modulo that. Okay, so we can get up to 10 to the power 5, right? Like we're shifting them by a value. So if I know 1 modulo that, I do know 110 modulo that, because 10 modulo that we are just multiplying with that number. So after that we'll try with 1111. We got that value. We can calculate it basically log of n. Yes, yes, perfect. And each test case, there are no more test cases, so we can just do, or we can just keep it right here also. So the thing is power of that module or something, and also the power of that modulo something, power of 10 modulo that. Okay, let me first get that factorial thing. Do I need factorial? Yes, I need factorial. Total number, then number. Okay, do I need factorial? Like how many arrangements can be there? How many combinations? So choosing that such numbers, we're choosing 5 such number. Yes. Yes, I think that is grouping them. Grouping. How many? No, it is not like grouping. 0, 0, 0, 0, 1. So we're taking. Okay, I can remember how many arrangements are there. Arrangements. That is like. From a set, we are choosing 3 values and we are permuting them. That is in choosing in CR. Now we have to check if that are distinct or something or like that. That was all distinct. Yes. Number of such arrangements. K can be very large. How many arrangements will be there? 0 0 0 0 0 1 1 1 2 distinct, then 1 any two preventing them those positions. And okay, the first position can take any of these two values. Second position can take any of. Wait, this is easy. That will be that r minus l plus 1 to the power k. Yes, perfect. So number of now. Okay, so bin pow. I'm just taking this binary exponentiation snippet from there. Bin pow. Okay, now to this side. Okay, okay, set valid. It works. Okay, so the thing is that we have to take long. Let's also take this long. Now y is equals to wait, bin power of r minus l plus 1 to the power k, and the sum will be we are taking contribution from each value, so it will be by r minus l plus 1 not minus 2. Now ll contribution will be with multiplied by now wait ll sum comes to 0. Come on. Contribution will be sum multiplied by with modulo mod number of times which occurs, right? Now we are taking the we got this some value and we have to get this thing now, right now. Okay, now 10 to the power 9. K is 10 to the power 9. That many digits are there. So I have to make a function to calculate this. 10 to the power 9. So we have to take the square root of that. Yes, that multiplied by this value greater than that value. Right. So multiplied by 2. 10 to the power 9. No, no, no. Cannot. Something multiplied by something. A multiplied by A. Okay, so A square. Square root of n is 10 to the power 9 square root. 25. Let's take it 25. Now we now this will calculate. Okay, this will calculate. Okay, wait, that is the sum. Okay, so we can represent. Wait. We do not need that too. This one we can represent this 1 that will be something like 10 to the power n minus 1 by this is the number of terms 10 minus 1, right? So we can get that value. So 10 to the power n minus 1, n is the number of digits. Is it true? No, it is not. N plus 1, so k plus 1. This will be k plus 1, because after that it will reduce to one digit, that will be k digit, then so k number of ones will be there. So 10 to the power k plus 1, right? Yes, ll 1 1 into 1 1 equals to bin power of forward 0 ll, so 10 ll to the power k plus 1, this plus mod minus 1, then this modulo mod, then 1 1 2 1 1 multiplied by bin power 9 ll mod minus 2, this thing, and this modulo mod, then return into 1 1. equals to mod. What's the correct number? 9 plus 7 1 1. So the first answer output equals to 111. Mm, but output is 6. Sum and ways. Sum is 3. 2 plus 1 3. Okay. Ways are 2. Perfect. So contribution is 6. Okay. Mm, yeah, perfect. Okay, I forgot to do something. It is 111, but it should have been something like 1 1. Yeah, okay, I think I need to just multiply it by contribution modulo mod 66 case 2 444 is 3 555. Perfect. Yeah, so all killed. Let's just replace. Okay, that was live at 106. Oh no, it's 580. Okay, what is this? One incorrect attempt. Okay, so that was it. So I can discuss the questions one second. Let's see the LLM. Damn, GPT and Gemini. Yeah. Okay, so let's see the questions. I guess. Yeah. So the first question was this: you are given an integer array nums. Consider all pairs of distinct values x and y from nums such that x less than y. X, y have different frequencies in num. Okay, so we're choosing any two number. I'm just brute forcing it. So the in num's length is from 100 and nums of by 100. So I just hashed the numbers. Then I checked if we are taking each pair and we are checking if the both have occurred in that array, and then we're checking if the frequencies of them are different. In that case, that will be the minimum pair we record, because we are moving from left to right. So that will be the answer and we will return that answer. And if we do not get any such pair, in that case we are just returning this answer -1 comma -1, what we require to give. So yeah, simple brute force, nothing else. Next, the question was merge close characters. So here we're at some distance. If the distance is at most k, then we can delete that. So we are just taking an offset, like from a b c. Okay, no, this will not give the offset. Yeah, this can be an option to see the offset. So a k equals to 2. So this a removes this a. So let me write that. Okay, I can teach you here also. So AA. Okay, if I do this, I think it will be better. Okay, just don't focus on the handwriting. What was that? AABCA. AABCA. So the first thing is we are we are checking from A. Can we go to this A, right? The distance k here, k equals to, I think k equals to 2 was there, right? K equals to 2, yeah. So the distance here, like from A to A, so 1 minus 0, the distance is 1. So we can always get this A from this A, right? I do not want to do that. This A, we got that A. So, and so what will be the index now? Just tell me the index after the deletion. 1, 2, 3, and this will be 4. To replicate this thing, we are introducing the offset. Here, offset equals to 1 because we have deleted one such number. So offset equals to 1 means from here, if we uh, from this number, if we go to any number beyond, there will be one less index difference because there was a number but it is not right now there. So that is it. Offset just makes it easier to calculate in order of n times time complexity, right? So just taking offset like that, then we are comparing b to 1, say not same character, actually not b, we are mapping. So from b we are checking if there is any previous b there. So there is no b, so let's suppose there is a b right here. In that case, this difference will be, if you see, let's make it 0 based. That case the difference will be 2 minus, okay, the indices would be, okay, let me rewrite this, and this will be 2, this will be 3, this will be 4, and this one 5. So the difference will be what? 3 minus 2, right? But there is not a character right here, so the difference will be 3 minus 0, that is 3, minus the offset. I'm just writing this OF. So that is the difference between these indices. So here offset is 1, here it will be 2, so the total difference will be 2, and if that is 2, we can also delete that, and after that offset will be 2. But the thing is that if we start from this index after that, then there is no such index where that offset will work, right? So that is why we are taking the prefix, this prefix of I. This will tell that there are that many offsets before this. So here the offset will be 2, right? So it will tell that there are 2 offsets before, and if there are x offsets between this character and a furthermore c, in that case the offsets in between will be x minus that prefix of uh, that index, that c, let's call it c1. So that will be the number of offsets in between that. Thus we calculate the effective distance between the same characters, and we will just delete this second if that satisfies that at most k criteria. So that was it. Now the minimum operation to make an array parity alternating. So if that is parity alternating, there are two cases, right? The first case is like odd even, then odd even, and so on, and the other case is even odd, and so on. So between these two cases we are choosing any case, and we're choosing a case, sorry, we are trying each case. So first where odd positions odd, so the odd position, that is zero best index, so this will be odd. So we are doing the state 2, condition 2, right? So configuration 2, so this is configuration 2. So in that case the odd indices are odd. So if the index is odd and the number is odd, then we are not changing that, because we have to do minimum operations possible. So in that case the maximum and minimum will be just that number, and else cases we can change that number, and we have to change that number. So answer 1 will be plus plus, and we we will try to reduce, because we have to minimize this maximum of nums minus minimum of nums. So we'll minimize the number for calculating the maximum, and we will maximize the number for calculating minimum. That is it. And similarly for the else cases, the odd, sorry, the even indices, and similarly for the next case, like the case 1. So we were just simulating these both these cases. Now if the answer 1 is less than answer 2, then we have to take the answer 1 and that value 1. And if answer 1 and answer 2 are same, then we will always choose the smallest value. So if value 1 is less than, then it will take this answer 1 part, and else case it will always take the answer 2 part. Like the second, sorry, the first configuration in here, right? And there is another check what I did it right here. If every number is same, in that case if we are doing this, so if every number is same, like n equals to 1, let's say, so the answer will be 0 and maximum minimum. Yeah, that case happens to be right, but I think there can be some cases where like each number, so we are decreasing one and increasing one. So we are like n equals to 2, let's say, and the first position we are not changing, the second position we are changing. Then if we are doing this, right, maximum less than this, minimum less than this, so maximum will be that number a of I minus 1. So this, let the number be 7, so maximum will be 6, and minimum will be 7 plus 1, 8. So the difference will be minus 2. That is not valid. But if we are considering two numbers, so the difference will be at least 1. So in that case we will minimize the, we will change the upper number, like the number that is maximum, to minus 1, and we can always change the other number to plus 1, that minimum number. So it will always be valid in that case. But if every number is same, then these conditions will not be valid, right? So, and this one case also, if the number, the difference, the number is only one length, so the minimum and maximum will be the same, and the difference will be 0. Okay, so we all, okay, so this case to check if all numbers are same. So then this, no, below case can't handle this case, like 2 2, right? And this will handle that case, and special case is n equals to 1. So that is what I did. Implementation could be better, but yeah, it's okay, I guess. Now this was a good question, I think, but I was thinking it pretty in pretty bad direction. Like this one, I thought to binary search it, kind of like binary exponentiation, but this just can do this and get that value. I think I told is pretty good. So still let's recap. The bin power, it will calculate in order of log the power to the power something. Mod is this 29 plus 7, and so from L to R, and ways, the number of ways we can uh, get different arrangements, like this one 0 0, we have 0 and 1. So each digit can take two values, right? So the first digit can take two values, the second digit can take two values, and the third digit can take two values. And every digit, uh, the take mm, the value that is taken by every digit is independent of value taken by the other digit. So we can just multiply them to get the total number of ways. So that will be number of digits, sorry, that will be the number of valid digits from here. I mean the valid numbers we can put in that positions. There are two, so this can be 2 2 2. So 2 into 2 into 2, that will be 2 to the power 3. So in general that will be, if that is of that will be of r minus l plus 1 possible digits in that position. So r minus l plus 1 to the power k, because each digit can take any of those r minus l plus 1 values. So that is what we did with. And now each case is equally likely, like the first digit it can take 0, it can take 1, and exactly half of the cases will be 0, and exactly half of the cases it will be 1. You can see it right here, 0 0 0 0. In 4 cases it is 0, and then in next 4 cases it is 1. So that is what we are doing. We are taking equal likely cases. So this is what we do in modular arithmetic to get 1 by r minus l plus 1. So we get number of times each occur in that position, in each position. So that is what, and each occurs. So like like the first one, let's make it ai, occurs in number of ways, plus ai plus 1 occurs in number of ways, dot dot dot. So will be that will be ai plus ai plus 1 plus dot 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 multiplied by this. So that is what I did. We took the sum, the possible digits, and then multiplied with the ways. So you get the total contribution in one digit of each value. Like here we can see the total contribution will be for each digit 0 0 0 0. So total 0, then 1 2 3 4. So it will be 4. The contribution will be 4, and in each digit it will be same. Now we have to multiply by this number, and we can write this number by this thing. And I made a mistake, that will be k, 10 to the power k. There will be k zeros. Yes, I thought that will be k plus 1, whatever. So there will be total k plus 1 digits and k zeros. So k plus 1 digit, then minus 1 k digit, then by 9 everything will 9, and by 9 it will be k ones, right? So that is what that is what we did. 1 1 pin power this to the power k plus minus 1 mod. Plus mod is to just make it positive in modular arithmetic. Now by 10 minus 1, that is 9. 9 ll mod minus 2 to the power mod minus 2. That will give that by 9 modulo mod into contribution. So in each digit there will be contribution times thing. So that will multiplied by contribution and we'll take the mod and we'll return that. So that is simple math code, I guess. Okay, let's see the length of the code. How much it is? Pretty short. Yes, it's pretty short. I hope you understood this. So that is it for today. See you in the next contest.